Parts 1 and 2 looked at how using specific formulae could create musical colours in the form of scales and chords. Scales and chords are just collections of sonic data which provide different outcomes according to the combinations of numbers that are used. However, this information would be nothing without movement. We can use more numbers and mathematical elements to create rhythm. Rhythm is the organisation of sonic data in relation to time, but unlike time itself, the pulse of the musical clock can be speeded up or slowed down. Musical pitches are arranged into small groups according to the beat of the musical clock, and these groups subsequently create patterns that we can recognise as being melodic, harmonic, or purely percussive. The musical clock can be thought of as the music's own heartbeat, and when the pulse of the music quickens, the more energetic the music becomes. But when the pulse is slow, the music will generally be calm and will create a more relaxing ambience. The musical heartbeat, known as the mother pulse, is measured in BPM, beats per minute. It is categorized classically by name according to approximate boundaries of speed. 30 beats per minute equates to 1 beat every 2 seconds. 60 beats per minute equates to 1 beat every second. 120 beats per minute will equate to 2 beats every second, and 180 beats per minute equates to 3 beats every second. The essential pulse or beat of music can be organised mathematically into units, which become either divisions or multiples of the beat itself. New patterns can be created that are felt as being quicker or slower, but still related in time to the mother pulse. If you take a whole of something and you cut it in half, divide it by 2, you'll have 2 of something, 2 halves. If you then split those 2 halves, you'll get quarters. Split the quarters and you'll have eighths. Split the eighths and you'll get sixteenths, and so on. We can essentially divide or multiply to create specific units of rhythm which relate to time, and each unit has its own name and mathematical representation. This type of calculation lies at the heart of rhythmic organisation. Let's look at the most common names and units of time. First, we have a circular type symbol called a semibreve, which is also known as a whole note. If you halve the semibreve's length, you create 2 half notes called minims. So there are 2 minim values in one semibreve. If you cut the length of a half note into 2, you will create 2 quarter notes called crotchets. There are 2 crotchet values in one minim and 4 crotchet values in one semibreve. If you halve the length of a crotchet, you will create 2 eighth notes called quavers. There are 2 quaver values in one crotchet and 8 quaver values in one semibreve. Cut the length of a quaver in half and you'll get 2 16th notes called semiquavers. There are 2 semiquaver values in one quaver and 16 semiquaver values in one semibreve. A whole note is a semibreve, a half note is a minim, a quarter note is a crotchet, an eighth note is a quaver, a 16th note is a semiquaver, and a very fast 32nd note is called a demi-semiquaver. There are even 64th notes called hemi-demi-semiquavers. The way in which these note values make sense is when they are organised into a time frame which comprises lots of little boxes called bars, and each bar is allowed to contain a specified number of beats. Any of the note values can be included so long as they add up to the specified number of beats. When you mix these note values up and insert spaces, known as rests, you create rhythmic patterns, and these are the life forms of music. Let's listen to the note values and their lengths in context by means of creating a very straightforward representative pattern. And here is the same basic pattern laid out on a drum kit. Simple and equal mathematical divisions, as you have just heard, do not create that much excitement rhythmically. Even though there are multiple parts, each part repeated its own specific time value over and over again. There was no variation. Each part needs to combine unequal time values, which are mixed in different ways, as this will create interesting rhythmical patterns. We'll explore this further the next time.